To explain what the teams can now develop, let's take a look inside the Formula E car and identify those key components. The Formula E car was designed from the outset to be modular in design to allow teams and manufacturers to develop the drivetrains so that electric car technology could be tested to the limit by the sport. The battery is the storage of energy, the fuel tank, if you like, of an electric car. The Williams supply battery is used by all the teams and it's made up of 200 kilograms of lithium-ion cells. This is the equivalent capacity of approximately 300 laptops or 4,000 mobile phone batteries. In all the cars, the maximum amount of energy the teams are allowed to use is 28 kilowatt hours. We see this on the TV graphics as 100% battery charge. This is in effect the amount of fuel in the car, and its use is strictly monitored by the FIA telemetry systems. But it's not just energy that's limited by the FIA. The cars can also only produce a maximum amount of power at a given time. 200 kilowatts in qualifying and with fan boost, and 170 kilowatts in the race. It's how they deliver this energy and power to the road that the teams can now develop themselves by building their own inverter, motor and transmission, known as the drivetrain. The inverter contains very high power switches that can turn on and off the current to the motor up to tens of thousands of times per second. The inverter therefore controls the electrical currents that are delivered to the motor that produce the torque and power to turn the wheels. For the electric motor itself, there are a number of different concepts in use, but they all use the same basic ideas. There are two main parts: the rotor that rotates and the stator that is stationary. The rotor has some very strong magnets attached to it, and the stator has many coils of copper wire. When an electric current is passed through the wires, it generates a magnetic field. The magnets in the rotor are attracted and repelled by the magnetic field, and this spins the motor and generates the power required. The power from the motor is then transferred into the wheels by the transmission. The motor can spin up to 20,000 RPM, and this needs to be controlled through gears. The size, maximum motor speed and number of motors will determine how many gears the car will need. There's a whole lot of technology being developed under the skin of the car, and the teams are in a race themselves to find out the best ways to use it.